Chapter 8, the Canonical Numbers and Mod 99. So while we've been using the Mod 9 lens, I discovered that it is also useful to use the Mod 99 lens. And what that means is instead of 9 digits on your timepiece, or 12, in this case, you've got 99. So you'd go from 1 all the way around to 99, and when you get to 100, you're back to 1 again. So that deals with 2-digit numbers and Mod 99. And where there was that trick, getting the Mod 9 answers, insofar as you just add the digits up, so 123 is 1 plus 2 plus 3 is 6. In Mod 99, you take the last two numbers of the number and then add them to the next two and the next two and the next two, and keep reducing until you've got a 2-digit answer. So instead of going for a 1-digit answer, you're going for a 2-digit answer. So a number like 1, 2, 3, Mod 99 would simply be the 2, 3, 23, plus the 1, 24. It'd be 24 Mod 99. So it's a little trick, will give you the answer. So that's the 2-digit numbers in Mod 99, and that lens has also proved to be very interesting. But I just want to switch back to the canonical numbers. So what do I mean by a canonical number? Well, I mean that a number that is balanced in its number pairs. So the number 27 is a canonical number. The number 3, 6, 6, 3 is a canonical number, balanced in their number pairs. 3, 6, 2, 7, 3, 1, 6, 8, 5, 4, 7, 2, 9, 0, 9, 0, 1, 8, 1, 8, 1, 8, 7, 2, 6, 3. All of these numbers and all of the permutations of those numbers and the relationships between them in the different dimensions, whether it's 2 for a number like 27, 3 for a number like 180 would be a canonical number. So would 189, 198, because the 9 is complete in and of itself, and the 8 and the 1 are the divisions of the 9. So those are canonical numbers, and I've done a lot more work in the next book on those things and the relationships between the two, and the beautiful ratios and numbers that come out of those canonical numbers. Basically everything comes from this specific canon of number that operates using combinatorics or combinations of each other. Back to the Mod 99, the way that I discovered this, I had all these numbers all over the wall, charts of numbers and geometries and all sorts, and I kept looking at these things, and I eventually discovered this technique of adding the previous two numbers to the next two in order to see that actually, hey, this is useful. And looking at the hexagram sequence of numbers, when you look at the Mod 9, it's not very interesting. Just 141 repeats over and over. But when you look at it in Mod 99, then it's a whole different story, because you get this, again, a 33-digit, well, it's not digits, but it's 33 single-digit, double digits sequence that repeats over and over. So there's 33 that then repeats again for 33 and another 33 and another 33 forever. And the beautiful thing about this, so it's centered on the number 17 and this number 49. But you can see that, so it's centered by 49, then either side is 55, then 73, then 103, then 46, then 100, both sides. So it's palindromic. It reads the same forward as backwards. So it's centered and it like opens like a flower, if you like, either side. So it's balanced on this number 17 by this number 49, which is obviously 7 squared. Again, we're going to find that a lot of what goes on is all a dance between the 2 and the 3 and the number 7. So it's 7 to the power of 2 is 49. 2 to the power of 7, 27, 72. These are the numbers that come up later. So, but what's interesting about 49 is pretty amazing. So the hexagram, it's generally sort of looked at and associated with light. And interestingly enough, the only octave on the electromagnetic spectrum that we can see is the 49th octave. Now, when I ran the Mod 99, so I ran Mod 99 over a whole bunch of different sequences. But when we got to the Platonic solids, none of them gave anything back that was interesting apart from the cube. And interestingly here, so we take that huge sequence of numbers and place them, we've put a 0 on the front there. You can see that even when they're double digits, they're still number paired up, which is mega. That was just amazing. Okay, so the next bit we're looking at number group analysis under the Mod 99 lens. So looking at all the different permutations of how you can put 3, 6, and 9, or 3, 6, and 0 together. So first with the 3, 6, and 9, so those are the 6 different variations. And in total, they add up to 3996, which is 36 Mod 99. So I do it like this. 96 plus 39 is 120, is 135. 35 plus 1 is 36. So you can just keep doing that by taking the big number, reducing it, and then taking the digits and adding it until you get down to the 2 digits. 3, 6, obviously a number pair. Then we do the 360 and all its permutations, comes to 1998, which is 98 plus 19 is 117, is 18. So now we've got a 1, 8 and a 3, 6. And then when you look, if you take these numbers and look at their Mod 99 values and then add them up, so 69 becomes 72, 69 plus 3, 96 plus 3 is 99, 63 plus 9 is 72, 36 plus 9 is 45. So when you add those numbers up, you get 432, which is your tuning. Then you look at the 147, add them all up, 2664, 64 plus 26 is 90, 9 and 0, number pair. And then looking at those, you get 288, and that number comes later in a big way. And then the 258, all the permutations, again 63, so it's the opposite of this one. So the 369 and the 258 are linked by their opposites there. But looking at these and looking at the Mod 99 for 258, the total of them comes to 360. So these are all starting to give us clues as to where these particular groups fit in to understanding of science, be it chemistry, physics, or biology.